My name is Antonia Bravo, and I lead growth and open source for Giga's technology team. Giga is a joint initiative between ITU, the International Telecommunications Union, and UNICEF, focused on school connectivity. Today, I'll talk to you a little bit more about our open mapping and GovTech work and how we leverage open technologies to expand access to internet across the globe. So this was the data shared by the government of Panama a few years ago when we first started working together. School data is usually shared on an Excel in a tabular format with many decimal points, though sometimes more numbers after the dot for some schools than for others. When working with this data, I find myself trying to reconcile different spellings of categorical data, different languages, different data types within a single column. Sounds familiar, no? Data is essential for our mission, but it is only the starting point. On the other hand, you have maps. This map is a geographic map of Panama divided into its administrative regions. And when data is plotted on top of a map, that data becomes even more tangible. Even one may add actionable. Maps are powerful precisely because they unite the abstract and the concrete. Rather than cells in a spreadsheet, we can instantly see patterns and relationships emerge. In this case, though, it's not very clear. We see red dots span across different regions. Maps enable us to condense layers of data into a single visual narrative. They ground these data points in physical space, revealing how, for example, socioeconomic or technological realities intersect, in this case, with the terrain itself. Notice here, for example, how you see red dots cluster around topographic features. We see a cluster around the Darien Gap in the bottom towards the Colombian border, but we also see one around the indigenous comarcas, the comarca Ngabe Bugle, for example. This is the autonomous territories of the Guna and Embera people. And while exact figures vary, estimates often indicate that over 90% of people in Guna Yala live below the poverty line, compared to about 20% nationally. So this map that you're seeing is a map of school connectivity, but it is also a map of poverty. It's a map of isolation, it's a map of structural inequities and of the digital divide. Interestingly, some of these schools, specifically those around the center of the country, are proximate to prime connectivity hubs. The lines here represent submarine cable landing stations. In internet terms, we have key arteries pushing bits to the country, and yet they do not reach schools and children in these areas. How do we begin fixing a problem we can't fully see? We start by mapping it and creating the go-to source of truth for school locations and their connectivity status. Now, planning connectivity without accurate information about school locations, their connectivity status, and distance to key connectivity infrastructure is a bit like flying blind. Giga is a joint initiative between these two organizations, and what we aim to do is to fray away at the information asymmetry that exists in the connectivity space, starting with school data. So we leverage government as well as open data, quite a bit from OpenStreetMap, and we work with governments very closely to collect, standardize, and improve government data. I invite everybody to visit maps.giga.global to get a glimpse of our map data and our broader work. Now, an open school location and connectivity map is essential for driving investments, optimizing resources, and tracking progress towards connectivity and digital education initiatives. Besides these maps, we also build open source software to, for example, monitor the quality and consistency of internet in schools over time. But our ambition is to build an integrated suite of tools and services that makes connectivity procurement efficient, transparent, and sustainable. Now, of course, building this map wasn't as simple as dropping pins on Google. You all probably know this. We needed data, and much of it sat siloed within governments. Convincing ministries to open up their school locations and connectivity stats is quite challenging. Officials worry about data accuracy, about privacy. Others didn't actually have an updated list of schools themselves. It takes patience, transparency, and trust to bring them on board. Now, why is open source important to this? 5 years into building this open tech project, we have been able to build upon other successful projects, as well as emphasize that data is not only for the government themselves. They enable, for example, humanitarian mapping, edtech companies to learn more about where their service offerings are across the globe. They aid internet service providers and local entrepreneurs to assess the market and find opportunities for service expansion. I'm a little bit over the time that I have allotted, so I just want to leave you with this final slide. We are sort of growing in the open source space, more of a nascent project, and we're trying to develop our internal dev practice and a community of contributors and maintainers. I'm here with my colleague, David, who's our community manager, and we would love to hear from you as we go on this learning path. Thank you.